Here we have our vertical motion model, and from the problem we can see that a baseball is hit straight up into the air. The baseball is hit with initial vertical velocity of 80 feet per second when it is 3 feet off the ground. In a vertical motion model, the h represents the final height, t is time in seconds, v is velocity in feet per second, and the s here is also in feet, but it is the starting height, just like the h. From the given information, we have that v is 80 feet per second, and the starting height, s, is 3 feet. Part A asks us to write an equation that gives the height in feet of the baseball as a function of time in seconds since it was hit. We just substitute the values that we know and keep everything else as variables. So we have h is negative 16 t squared plus 80 t plus 3. And that's it for part A. Part B asks us to figure out after how many seconds does the ball reach a height of 99 feet. That 99 feet is our final height, h equals 99, and we're going to substitute it into the equation from part A. And we have negative 16 t squared plus 80 t plus 3 equals 99. In order to solve this, we need to bring all the terms over to one side. We're going to subtract 99. We have negative 16 t squared plus 80 t minus 96 equals 0. And each of these is a multiple of 16, and usually it's difficult to work with a negative as your first term. Let's just divide everything by negative 16. And you can do this because we're doing it to both of the sides. We end up with t squared minus 5t plus 6. Negative divided by negative is positive. And then 0 divided by negative 16 is just 0. From here now, we just need to factor. Only way to get t squared is t times t. And now we need two numbers that multiply to give us positive 6, but they add up to give us negative 5. Those two numbers would be negative 2 and negative 3. You can quickly distribute this. Just verify that you would get what you have above. And now that we have the factors being multiplied and set equal to 0, we could apply the zero product property. We have t minus 2 equals 0, t minus 3 equals 0. Add 2 to both sides. We get that t equals 2. And we add 3 over here. We get that t equals 3. We have two solutions, positive 2 and positive 3, both of which are possible because in this case time would be positive. Here's our solution. The ball reaches a height of 99 feet after 2 seconds and after 3 seconds from when it was hit. Finally, part C. Does the ball reach a height of 99 feet more than once? Justify your answer. Well, from our solutions, we could see that yes, it does reach it more than once. To justify the solution, we could look at the graph of this function. Here's a graph of the function h. So the ball is hit from 3 feet. As it's ascending, it passes a height of 99 feet, reaches its maximum height, and as it's descending, it passes through that 99-foot height again before hitting the ground. And the graph here, although not shown to scale, does show that the ball does reach a height of 99 feet twice, as does our answer over here.